Good evening, I am Marinel B. Espinosa and I will be discussing about the compass, types of compasses, magnetic declination, and I will be giving an example on how to solve the magnetic declination. So let's start. The compass. The compass is defined as a handheld instrument used for determining the horizontal direction of a line with reference to magnetic meridian. So later on, we will know of what a magnetic meridian is. In the book, it is said that the compass has been used by many people in navigation for centuries. Though this kind of instrument is no longer used for surveys requiring high precision because it cannot provide accurate measurements, it is still used for preliminary surveys, exploratory surveys, and retracing old land surveys and directions measured by more precise methods because of its probability. The compass is a highly beneficial instrument for people like engineers, surveyors, geologists, and foresters. There are essential features of the magnetic compass, and these are the compass box, line of sight, and the magnetic needle. The first one is the compass box. The compass box is the box of the compass. It is used to house or cover the above parts of the compass. The next one is the line of sight. A line of sight helps to sight the other end of the survey line through the compass. And the last one is the magnetic needle. The compass needle is a piece of magnetized steel placed at the center of the compass, used as an indicator on the dial of the compass. The purpose of the magnetic needle in the compass is to determine the magnetic meridian. Types of compasses. Magnetic directions, such as bearings and azimuths, are determined with the use of a compass. There are various types and design of compasses available. Some of these instruments are named after the intended user, the designer or manufacturer, a particular application, or according to its design and main features. Some of these compasses include the following. The first one is the Broughton compass. The Broughton compass is defined as a fancy, highly precise compass mainly used by geologists for navigation and also to measure the strike and dip of rock layers in the field. During the surveying operation, the Broughton compass can be mounted on a tripod or just held in one's hand. This type of compass is only suitable for the surveys that require only low degrees of precision. Next is the lensatic compass. It is the current US military compass. Compared to other kinds of compasses, a lensatic compass allows you to read the bearings while sighting the objects all at the same time without changing eye position. It also has the sighting wire, which helps in determining the azimuth more accurately. Next is the surveyor's compass. The surveyor's compass is an instrument mostly used by surveyors not only for measuring horizontal angles and for determining the magnetic bearing of a line of sight, but also used for forest surveys, in retracing old land surveys, and in geological explorations. It is also known as the circumferentor. And the plain pocket compass. The plain pocket compass is a type of compass that is the same with a surveyor's compass, except that it has no sight vanes. It is a small hand instrument used for obtaining roughly the bearing of a line. Various pocket compasses are used in reconnaissance and exploratory surveys. Next is the prismatic compass. The prismatic compass is a surveyor's hand compass provided with a triangular glass prism so adjusted that the compass can be read while taking a sight. So, unlike with the other mentioned types of compasses earlier, some of prismatic compasses are filled with liquid and hence are referred to as liquid compasses. Liquid prismatic compasses have been widely used by sailors for navigation at sea. Next is the forester's compass. The forester's compass is a pocket compass which is usually made of aluminum or some type of metal which does not affect the free movement and positioning of a magnetic needle. From the name itself, forester's compass, this type of compass is best suited in forestry surveys, and not only in that, but also for geological and other similar exploratory surveys. Is the transit compass. The engineer's transit has a compass box which is similar to the construction to the survey's compass. This box is mounted on the upper plate of the transit and often used to check horizontal angles and directions measured or laid off during transit surveys. It is also used for orienting the transit with the magnetic meridian. Now let us move on to the magnetic declination. So in a compass, there is a true meridian, magnetic meridian, and the magnetic declination. The true meridian, or what is labeled in the picture as TM, capital TM, is classified into two, which are the true north and true south. These are points in the compass that are fixed, while the magnetic meridian, or labeled in the picture as MM, capital MM, are points that changes depending on the time and location where the compass is pointed. Now, the horizontal angle formed in between of this true meridian and magnetic meridian is what we call the magnetic declination. The magnetic declination may be classified into two types. One is the east declination, and the other one is the west declination. When the needle of a compass points to the east, or when the magnetic meridian is at the east, the angle formed in between the true meridian and the magnetic meridian is called the east declination. While when the needle of the compass points to the west naman, or when the magnetic meridian is at the west, the angle formed in between the true meridian and the magnetic meridian is called the east declination. Declinations are being considered in order to find the length of bearings. These are the magnetic bearing and true bearing. Magnetic bearing is an angle measured from the magnetic meridian to the line. On the other hand, the true bearing is an angle measured from true meridian to the line. Azimuth. So when determining the azimuth, you always have to start from the north direction and turn clockwise in the compass. Azimuth angles always have to be between 0 and 360 degree only, and shouldn't be more than that, because a compass has only 4 quadrants, and each quadrant is equivalent to 90 degree. Why it is equivalent to 90 degree? Because each quadrant is right angle, and right angle is equal to 90 degree. So if you multiply 90 times 4, it is equal to 360 only. That is why the value of the azimuth must only be between 0 to 360 degree. Unlike bearings, azimuth are called by just indicating angles. So here is a sample problem of a magnetic declination. The magnetic declination in a locality is 2 degree and 30 minutes east. Determine the true bearing and the true azimuths reckoned from north and south of the following lines whose magnetic bearings are given. So these are the given magnetic bearings. And here is the given magnetic declination. Before we proceed on solving the problem, let us know first these symbols. So D means the magnetic declination, and this sign or symbol is the magnetic bearing, means the magnetic bearing, and P is the true bearing, and this pi sign is the true azimuth. Now earlier I have tackled about the magnetic meridian, magnetic declination, and the true meridian. Pero yan na, i-show ko ya a graph para mas maintindihan. So in a graph, this is the true meridian, and the true meridian is classified into two, which is the true north and true south. And here is the east and west. While the magnetic meridian liwat, kay let's say, ito magnetic declination is 2 degree and east 2 degree east. So amay ni it no. So this is the magnetic meridian. And the angle that will be formed in between the true meridian and the magnetic meridian is called the magnetic declination. So may nian magnetic declination. Now it pagkuha hit magnetic bearing and true bearing kay, let's say it magnetic bearing kay adding ani. So from the magnetic meridian pakadi hit line kon let's say A and B ini. At pagkuhalawat it true bearing, kay tikang ha true meridian, pakadto ha line AB. Now it pagkuhalawat it true azimuth, kay must start ka always ha north clockwise. Ngan each quadrant is equivalent to 90 degree, kay right angle 90 degree and 90 degree and 90 degree equals to 360 degree. Okay, amalad to. So, ma-proceed na kita ha solving. Let's start ani ha letter A. I-write ko it mga given. So, the given are the magnetic bearing and the magnetic declination. D is equals to 2 degree and 30 minutes east, and the magnetic bearing is equals to and 25 degree 40 minutes east. Now, let's graph na hiya. I-plot na natin hiya graph. Amay ni true north ngan true south, east and west. Since nakabutang nga di kay iton magnetic declination kay 2 degree ngan east, so east adit hiya di. Bali adit hiya nga di na quadrant. So 2 degree minute magnetic declination, magnetic meridian, thus an angle formed in between the true meridian and the magnetic declination is the magnetic meridian. The angle formed in between the true meridian and the magnetic meridian is called the magnetic declination. Next, and magnetic bearing. Now, kay nakasart nga di kay north, so adit hiya di. It's either adi nga ni na quadrant na duwa. Tas ta kay east, so adi nga di. So, from the magnetic meridian, 25 degree, amay na niya di da. Let's see, amo nga da. Iton, line A, B. Amay nit, magnetic bearing. Now, it can identify kay ano ko no iton true bearing, which is kailangan natin i-measure tikang ha true meridian pakadto ha line AB. So, its formula of finding the true bearing is equals to true bearing is equals to magnetic meridian plus or minus the magnetic bearing. Singon ta na letter B. Plus or minus kay nadepende ya kung hain naka-place iton magnetic declination. So, bali, the B is equals to letter D. Since adi man lahiya, so adi man hiraha usa na quadrant, igaad mo la inihiya na duwa. D plus the magnetic bearing. So 2 degree and 30 minutes plus 25 degree and 40 minutes. Mayus kitan calculator kay kung diri na kukuha tama na answer. So 2 degree and 30 minutes plus 25 degree. Ay, ano ba ito? 2 degree. Ay, sa'yo. 2 degree and 30 minutes plus 25 degree and 40 minutes is equals to 28 degree and 10 minutes 28 degree and 10 minutes. So bali may need aton true bearing. Butang ko laan iya label. Unahin niya naka-place north, east. May need aton true bearing. Next, kailangan natin i-identify iton iya true azimuth. Tikang ha north, pakadiha line, mantikang ha south, pakadiha line A, B. So, tikang ha north, pakadiha line A, B. Balit, maging kuan. Since na-answer na natin iya value, tikang ha north, pakadi, at true meridian, pakadiha line A, B, which is amay ni. So, bali, i-rate lang natin P is equals to 28 degree and 10 minutes. Amat iya true azimuth from north of line AB. Next, kailangan lotit natin i-identify tika nga south, pakadiha line AB. So since umagiya quadrant 1, which is 90 degree, plus another quadrant, which is 90 degree na lewat, so bali 180 degree, plus ini na quadrant, plus kunperaan answer nga di, which is ang letter P, plus P is equals to 180 degree plus adina value 28 degree and 10 minutes. Let's say gumamit na kitang calculator. So it i-answer kay magiging 208 degree and 10 minutes. Sa may niyan iya answer true azimuth from north of line AB, and this is the true azimuth from south of line AB. Next, let's proceed to letter B. So in letter B, the given are di amalagyapon, kaya amalagyapit magnetic declination na given. So 2 degree and 30 minutes is, tapos ang letter B nga magnetic bearing iba na, which is amay ni S 50 degree and 12 minutes east. Now, igpa-plot, tanggalan kayo ni kay para dire makonfuse. Now, igpa-plot na natin i-graph true north, true south, east, west. Since malagyapon inihiya at magnetic declination, so i-separate ko lagyap nga nihiya spot sa galaya. This is the magnetic declination. And since iba na adiya, so iba na ito't magiging result na di. Iba na ito't magiging result na ni. Since kikita may ni kung na adiya south or adiya north. Since nakarate nga di kay south, so aditiya it's either nga di na hain nga ni na duwa nga quadrant. South is, so aditi di. So from here, from the magnetic meridian, igme-measure mo iya 50 degree and 12 minutes. So let's see, amatiya is the line AC. Amay ni it line AC. So now we have to find the true bearing. The true bearing, it pag-find kay tikang ha true meridian, pakadaha line AC. Pakadaha magnetic bearing. So it formula D
is equals to, P is equals to, since itging kukuha man la kay inihiya nganhi, so, an whole nga magnetic meridian, igma-minus mo la, hakumpera inihiya. So, bali, a whole magnetic bearing, igma-minus mo la, ha-value iton, magnetic declination. Kaya mo man formula, magnetic declination plus or minus the magnetic bearing. So, igma-minus na. Ito't magiging formula. The magnetic bearing, ini nga magnetic bearing, igma-minus natin ha, magnetic declination. So, bali, 50 degree and 12 minutes minus the magnetic declination 2 degree and 30 minutes is equals to, let's say nagkalkula ako, 47 degree and 42 minutes, it answer. Amay aton true bearing. Amay niit true bearing. Butangan ko lang kung niya nakakuan, which is Adya South, tapos Adya East. So, amay tiya. True bearing. Next is we will find the true azimuth. Tikang ha north, pakadiha line AC. So, tikang ha north, since di rin man natin ma-identify kung pera init value, so bali, umagiha o sa quadrant 90 plus another quadrant 90, so 180 minus kung pera inihiya para nat masabtan kung pera ini, para masabtan natin kung pera true azimuth tikang ha north pakadi line AC. So, P is equals to 180 degree minus 47, and natin true bearing 47 degree and 42 minutes is equals to 132 degree and 18 minutes. A true azimuth from north to line AC. Tikang ha north, tikadiha line AC, it iya true azimuth value is 132 degree and 18 minutes. Next is we have to find the true azimuth tikang liwat ha south. So, tikang ha south, pakadi line AC. Kaya no, di rin nalaya mag-shortcut pakadi. Kahit pag-find it through azimuth, always clockwise nalibot. Pakadiha line AC, pakadiha line kunhay niya. So, asya ito nalibot kita. So, first quadrant, 90 plus another quadrant, 90. So, kahit may di another quadrant na lilipoton, diri na natin niya i-add into 90 na liwat. Kaya maaaring makita value compare ini. Since nakuha na natin ang value ang true north. Awan, ang true azimuth ha north. So, i-add lang natin aniya 180 plus aniya true azimuth nganhi. So, bali 180 degree plus ang true azimuth is equals to 180 degree plus 132 and 132 degree and 18 minutes is equals, kung nagkakalcumot, answer kay 312 and 18 minutes. Sa malad to, south, from south to line AC. Sa maladteya. Amoy niyan ang true bearing, true azimuth. Next is letter C. Ang letter C liwat, same lagi ang given. Same lagi ang given nga magnetic declination 2 degree and 30 minutes east, while aniya liwat kuanan area magnetic bearing kay nag-iba na sa amay ni south 62 degree and 18 minutes west. Next kay pa-plot natin iyang nga diagraph. True north, true south, east, and west. So same lagi hapon aniya magnetic declination which is 2 degree. Now aniya liwat magnetic meridian since magnetic bearing since adiya south, so it's either adi nganhi and takay west, so adi yang adi. So from the magnetic bearing 62 degree and 18 minutes hiya pakadi west, which is, let's say amoy ni amoy it line A D. Tika nga di pakadi. Sorry, na para di malipat. Amoy iton magnetic bearing iton line AD. So, ito kailangan i-find kay kumpara iton true meridian. Ini. True meridian. Ni. Now, true meridian is equal to igaadla naton iton value iton magnetic iton declination katapos iton iya compare niya nga magnetic bearing. So plus the magnetic bearing is equals to 2 degree 30 minutes a day plus 62 degree and 18 minutes a day is equals to 64 degree and 48 minutes. Takay adiya west, so west. Manhin adiya south, so south. Now, may nanakitahan true bearing. May nan true bearing. Yan aliwat, ipa-find na natin ang iya true azimuth. True azimuth, tikang ha north, pakadi ha line A. Line AD. So, the true azimuth of here, pakadi is, since umagihiya ha 1 quadrant 90 plus another quadrant 90, so 180 plus igaad mula inihiya compare it value nganhi, which is another true bearing. So 180 plus the true bearing amoy aton true azimuth from the north of line AD. So ikakadi ko 180 plus P is equals to 180 plus 180 degree. Don't forget 64 degree and 48 minutes is equals to, i-reach ko na like rated answer, kamo na like pag-calculate 44 degree and 48 minutes. So this is the answer. True azimuth from north north of line AD. Next is, we are going to find this. Since iton true azimuth ha south pakadto ha line AD, kay given na, kay nakuha na natin niya nga diha natin true bearing. So meaning, a true bearing is equal to the true azimuth from the south to line AD. So bali, malatiya. So, ay sayop ngayon. Dapat ngayon, sugad. So bali, compare value P, 64 degree and 48 minutes. So, may niit aton true azimuth from south of line AD. Malad to.